everybody. Welcome to the ONOS TST meeting. Today's topic for discussion is the FlowRule API and specifically the semantics of the add/modify operation. Do we want to preserve them? Do we want to change them? The discussion is going to be led by Carmelo and Brian, specifically, who have the more details on the context. So I'll let you guys take that over. I presume you're going to start, Carmelo, right?
Yeah. Can you see my screen?
Yes. Nice and clear.
Yeah, okay, so I have a few slides to get the discussion started. Yeah, so I guess our idea for today was to present the problem we faced in the last weeks and seek for advice from the whole TST on how to proceed. So to give you some context, Brian and I we actively participate to the P4 Runtime working group, which works to define the P4 Runtime API. And we have proposed in the past weeks a change to the update mode. So in P4 Runtime, there's a generic way of writing state to the device. We have the same update message for table entry, groups, all the type of data plane state you can write. And currently, this update mode provides three types, which are insert, modify, and delete. And our proposal is to define a fourth type that we call apply, or we can call it insert or modify. It doesn't make any distinction between the two, insert and modify, but simply tells the switch to make sure a given piece of state, for example, a table entry, is applied to the devices there. So it's inserted, it's created if table entry with the same key was not present before, or it's modified if a previous key was there. Now, this proposal has not received real pushbacks, but there are some concerns from the other folks in the working group, mainly Google, which also is building a P4 Runtime controller, saying that they don't see the real benefit of this proposal because their in their design, the controller owns the state of the device, well, like we do, and they think that they favor a more disciplined design in which the controller should always know what's the current state of the device, and in this case, be able to distinguish between insert or modify operations. The reason why we propose this is that to make this distinction between insert and modify operations in ONOS, we need to maintain some, yeah, actually, sorry, the slides were swapped. So this is the one I want to present first. So the reason why we made this proposal to the working group is that the existing FlowRule Service API in ONOS, as we know, it acts as a distributed authoritative flow table where the master copy of the flow rules lies in the controller, and the controller, makes sure that the same state is applied to the device all the time. And we do this using a reconciliation mechanism. But the other thing is that the API to actually write state looks like something like get, apply, remove, in which there are no modify or update semantics. So we have this apply method that either that is used to either insert a new flow rule or modify an existing one. And it seems that we're happy with that because ONOS applications do not care about previous state of device flow tables. For example, apps today don't know if if they are replacing a flow rule that already exists. And there's also another issue I'll discuss about this at the end, which is, by looking at the API, it seems that the semantics are that of a get, apply, remove. But then if you look at implementation and actually the API of the FlowRule batch operations, there are some traces of modify semantics, but that are never used in the code base or even in the OpenFlow self-found. So why this proposal, where it comes from? Well, it comes from the fact that to make this distinction between insert and modify operation, we had to implement some extra complexity in the driver layer of P4 Runtime. which is not really justified by any benefit for applications, because as we said before, apps only see an API that looks like apply or remove. There's no modify or update semantics. So this, I try to depict here how the P4 runtime sub-1 work today. So we have the FlowRule manager, the FlowRule store. We have in the core also this, what we call translation services that are used to translate flow rules to P4 program specific table entry. Then we have our FlowRule programmable implementation. And we have this component that we call a device mirror that lies in the driver, the P4 runtime driver, and basically maintains a copy of the state of the device. And it's based on eventually consistent map. So what we do, we map a table entry key, which is usually a match key, to an actual table entry. So the way the FlowRule programmable works is that for every get operation, every time the get operation of the FlowRule programmable is called, we create a device state with whatever is returned. We sync the mirror with the device state, so we make sure the device mirror is always in sync with the device, and we return the flows using the translation service. Similarly, when we want to perform an apply, we write the device state, but before doing that, we check the device mirror. So if the same key, match key, is present in the mirror, then we define a modify operation, otherwise it will be an insert operation. If the write operation is successful, we update the mirror and we return the applied flows. And similarly for remove operations, we remove table entries also from the device mirror before returning the flows. So this is working today. We are always able to converge to the desired state on the device. The issue is that because ONOS is a distributed system, and we are using an eventually consistent map of this device mirror, because I think this is the right primitive, because we care about performance in this case. Sometimes we can end up in a state in which two mirrors, two instances of the device mirror are not in sync. They don't have the same state. So sometimes we end up, issuing a modify operation instead of an insert, and so the device returns an error. So in the current implementation, sometimes it requires up to one reconciliation cycle to make sure that our table entries are applied to the device. We could implement a mechanism in which we react to specific error codes from the device. So for example, if we try to insert and the device returns already exists error, we could immediately issue modify operation. Clearly, this is better because in this case, it doesn't require a full reconciliation cycle, but only one run tree time between ONOS and the device. But here, the point again is that we are maintaining an extra layer of complexity in the driver that has no real justification for applications. What about OpenFlow? Well, OpenFlow, it's interesting because initially the first versions of the specification, they had very relaxed semantics for add and modify operation. I don't remember well, Brian did some investigation on this, but I think that either add or modify had the semantics or the other. So for example, modified also inserted flow rules if they were not present, something like that. But after the version 1.2 of the specification, actually with version 1.2, they changed this and they made a clear explicit distinction between add and modify operations, like in P4 runtime today. However, it seems that we never used the modify or so-called flow mode in ONOS. The only place where we actually generate flow modification messages, it's only for batch operations, which are never used. I mean, modify batch operations are never used. We only use add or remove batch operations. And also I talked to Charles briefly about his experience working with implementations of OpenFlow switches in production. And it seems that the switches we're using for Trellis, they treat add as an add or modify if exists. So it seems that the semantics in the OpenFlow world is still pretty ambiguous, and the world is leaning towards an API that is similar to the ONOS Norbound API, so apply remove.
I may need to make a correction. I don't remember I say that. I think it's from the switch side, it's still distinguish a flow mod message different flow mode message. I think it's somewhere in the OpenFlow southbound that do the translation. If you look at the a real OpenFlow message being generated, I think you can probably find the difference over there.
Yeah, so I tracked down to the OpenFlow rule provider, and we discussed about this
not a
last
provider.
week.
I'm talking about the protocol.
Yeah, so this is the flow rule provider.
This is the protocol.
Apply flow rule. This is the apply flow rule method. If we look at the implementation, apply flow rule, we always generate a build flow add.
Oh,
so
interesting.
This is the flow add operation. Indeed, if we look here, send message, we have support for wait, let me make this bigger. So we have support for flow modes. So the flow mode builder. It's only used in the when we generate batch operations.
Yeah, the batch. Okay.
Yeah. If we look at this, I think it's used only in test. So it's used in the virtual networks.
But since we have that batch operation, the app should be able to use that, right?
Yes, but for example, in your pipeliner implementation,
yeah,
charts,
but app most of the time the app don't care.
Yeah, you never use it. So I'm using your example as a prominent example of with switch and OpenFlow. Sorry, switch and controller OpenFlow implementations. In the FlowRule driver provider, for example, we do this. Wait, where's that?
So I think apps shouldn't care about that, because when you apply that flow into the FlowRule store, it is the store's responsibility to tell if the thing's already there and it need to update, or this thing doesn't exist in the store and it has to be added.
Okay, yes, so this is the point of the discussion today.
Yeah.
Before I move to the next slide with questions, so can you confirm that in your case, I mean, in your experience, OpenFlow switches use, you never use modify operations, but you actually modify flow rules on the device. Is that correct?
I modify the flow rule in the device, yes. You're talking about the app, right? You're asking
No,
if
I'm
the
talking
app
about the pipeliner, which in this case, yes, is the one talking with the flow rule service.
Yeah, I think so. I think we never use modify.
Yeah.
Well, Carmelo, one thing, just to be clear, the spec isn't ambiguous. The spec says after 1.2, this behavior should not be supported.
Yeah, sorry, I didn't mean the spec is ambiguous.
The implementations of the switches that we're using for OpenFlow 1.3 all just happen to maintain the old semantics, which is the add or modify if exists. And yeah, this is behavior that we put into the system back in the OpenFlow 1.0, maybe 1.1 days, and our implementations that we've used have not like our implementation, their implementations have not updated to the latest versions of the OpenFlow spec.
Yeah, so I think the thing is that if you can go back to page 3 where you have this diagram. So the thing is that I think the app shouldn't care about add or modify. What app care about is that this is the desired state I want to push to the FlowRule store. And once that's get into the FlowRule store should be able to distinguish whether this operation is a new added operation or an update operation. And then it should let the underlying system know that, whether I want to generate an add operation or a modify operation. So I think, I don't know, for me, it doesn't really quite make sense to have a duplication in the driver, because you already know all these information in your FlowRule store.
You mean device
so why don't
mirror?
Your FlowRule store generate some kind of event that tell the driver that, hey, this need to be a modify operation?
Yeah, we could explore an approach like that. The reason why I duplicate some state, I think you're talking about this device mirror, correct?
Yes.
Yeah. So the reason it's written here. The reason why I duplicate the state of the device in the device mirror is because in the P4 runtime driver, we use translation of flow rules to table entries. And it is not guaranteed that the same flow rule will be mapped to the same table entry. So, in the future, when we'll support swapping the pipeline on the device, it might happen that that one flow rule is mapped to a different match key, and we don't have a way to remember what was the old match key. I mean, that's mainly the reason, because there's this translation in the middle in which the representation of a flow rule can change based on the pipeline. So it seems more safe to maintain some state that was specific to the type of device, P4 runtime in this case. But I agree with you. We could find ways to make the flow rule store aware of this, and have the flow rule store suggest if this should be an add or modify operation. However, if there is no real benefit for application, right, and we have the possibility of changing the P4 runtime API. So my question at this point is, I mean, what's the right switch? What's the right switch API? I mean, if we're not really getting any benefit out of it, do you think it's worth defending this proposal in the P4 runtime working group, in which we simply don't make any distinction between insert and modify operation with simplified implementation with the controller? Or if we see that there are some benefits to have an urban API in ONOS that instead makes a distinction between insert and modify, like for example what Google does, maybe we should discuss about that and make more explicit what are our intentions in the ONOS FlowRule API. So I mean, I hear that Charles says that yes, we could have this distinction between insert and modify operations implemented as part of the FlowRule manager and store. Yeah, so my point is that
I think that would be the right place, because the app really shouldn't care about that, right?
Yeah.
But the FlowRule store, once you write into it, it should generate some sort of store event, and those should be able to distinguish is there an add or update, right?
Yes. Yes, I agree with you. But again,
and then Flow Manager will trigger the underlying programmable things, and then when we get triggered, we should have a different API for that. If we decide to go down the path of insert modify separation, right?
Mm-hmm. Well, again, it seems so. Charles, you say that you don't see any benefit in having this distinction between insert and modify operations from the application perspective.
From app, it shouldn't really care. The app doesn't really care, right? So the app just want to make sure this is the desired state. I push that. Whether you have something over there or you don't have something over there, it doesn't really matter. I want to change it to this one, right?
Mm-hmm.
What about when there are multiple apps and they may not necessarily know about each other?
Well,
if you do update or modify, if you do an update or modify, what you're really saying is, I don't know the existing state, and please make it look like this. And is that the semantics we want?
Yeah.
Okay, David, can you repeat the question? What if there are multiple what?
So what if there are multiple apps and they start stepping on each other?
Operate on the same flow.
Right. If I do an insert and then the flow already exists or something like that, then at least you get an alert that I might be stepping on something if there happens to be some sort of conflict. If I do an insert or modify, you remove that possibility of detecting a conflict.
Yeah, I agree with you. Well, we have examples of that cases today. So, for example, if you run the reactive forwarding application and the host location provider, they both try to write a flow rule that matches on either type IPv4 and send the packet to the CPU. But they insert this flow rule with different priorities. So what you see is the flow rule manager at every reconciliation cycle, trying to apply the missing one and removing the applies because the device clearly can only hold the device with the a flow rule with the same Mitch key once. You see the flow rule manager, at every reconciliation cycle, flapping between the two priorities. So this is an example in which applications are not aware of the situation. They think their flow rule is there and it's installed. This is not causing any real problem right now, but yeah, applications are not aware of that. So I don't know what's the best approach. I don't know if we should just log this event and have application developer realize that they're probably stepping on other flow rules from other applications.
Carmelo, one question on this, so in this case of the two apps installing the same flow rule and us cycling over them, why don't we also implement the hashing mechanism in the sense that if there is the same hash excluding the flow ID, which is something that will differ, if the same match and action hash to the same string, why don't we also say it's something that's already there?
Yeah, so you're saying that the flow rule manager and store, they should be aware of the flow rule semantics. So if someone tries to insert a flow rule that matches on the same match key and has the same action, maybe different priorities, maybe the flow rule store could do something to merge these two flow rules together.
No. According to OpenFlow spec, the priority is also part of the key to identify the flow. So it's the priority plus the selector. So if you have different priority, then they should be treated as two different flows.
I know, but okay, understand. But if two applications, so if one application inserts the same flow,
I think this is a valid argument that we can potentially have multiple applications working on the same, operating on the same flow. I think this discussion is out of scope because in that case, the solution provider should really ensure that all the apps that you're providing in this product shouldn't have that problem, right? Otherwise, you will have more problem than detecting.
I think I'm not sure I agree with that. Just from the perspective that this means that I essentially have a controller that can run a app, or I have to then get all my vendors to agree that, hey, I'm going to run you in this context and expect it to work, and you better go modify it so it does. I think it's a general problem in SDN and OpenFlow control and probably P4 control. How do you do with multiple applications that you really don't want to know about each other? You want to be able to operate them in isolation, yet use the same controller.
But even if you can know that stuff, the controller has no knowledge of resolving that conflict, right? So it's still up to the app developer to resolve that conflict if there is a conflict.
So yesterday, Ray made this. It compared this case with two applications on your computer overwriting the same file. So I think there are two ways of approaching this problem. In the first case, if an application just overwrite the files of another one, the other application probably will never know. She just realized that the original file is missing. But operating system today also provide APIs to set specific permissions to files and have special flow rules that cannot be special files that cannot be modified by others. So perhaps this could be an approach that we could explore, in which by default applications insert flow rules, and those flow rules can be replaced by other applications. But we can have special flow rules that have special permissions, and once in the system, they can only be modified by the original application that created the same flow rule. Because otherwise, I think that, as Char said, I think it's very hard to think of a way of to resolve conflicts, either in the implementation of the flow rule manager or store, or even in the application implementation. What the application will do if realizes that a flow rule with the same Mitch key it wants to insert is already present in the system. We just log the error. Which is probably would just avoid programming the network at all and display a big warning to the to the user?
Yeah, these are all good ideas, but I think the scale of this discussion is way much bigger than what we plan to do today. But having said that, I do agree with David that there could be some benefit of separating insert and modify, so the application can know after insert if the stuff is already in the store or not. I think the app can still benefit from that part.
Yeah.
So if we kind of ignore the thing of having multiple apps conflict with each other, but even just with a single app, I think there is a benefit of the app knowing after an insert, if that's a there is some sort of indication that you're overriding something or you're adding a new stuff. I think there is a benefit of that.
I think there's a benefit to say, I'm going to try to push this flow down, and if it already exists, I want an error. I don't want it necessarily to modify.
So Charles, since you're saying that the API should be the same to write flow rules, but application should have a way to know if that was an insert or modify operations, correct?
I don't know if we want. I mean, my point is that the app should be able to know whether we want to use a separate API or the same API but with some sort of return value. I don't have a strong opinion on that, but I do think we should. The app should be able to know whether it's a write or update, insert or update event. Just like the store we have today, if you apply something to the store, if you do .insert, then it will return null if there's nothing there, right? But they will return the O value if you step on someone else, right?
Mm-hmm. Do the others have any opinion?
So maybe I'll just mention two things that were part of the pushback for this proposal within the P4 working group. The first one, it comes down to the fact that the semantics of create versus apply differ in who controls allocation of new resources. So in a system where you're just dealing with memory, and memory is infinite as an abstraction provided by the kernel, it's pretty free to allocate DRAM for in memory maps and structures. But on the ASIC, actually, some of these applies require somewhat complex allocation of an ASIC resource, or somewhat carving of an ASIC resource. And the point here is that the owner of the flow state, as some of the opinions in the working group, is that the owner of the flow state should be responsible for making an allocation decision. So an allocation decision should not be made sort of passively, when you, as a result of some action. And it should be done by the control plane.
But I'm not sure this is a valid argument, because a flow table is essentially a map that maps keys to actions, match keys to actions. So here we don't have the possibility of either inserting a new key or modifying an existing one. I mean, if we want to match on certain packets, we want that match key to be in the system. So
yeah, but the thing is,
if you want it to be there and it already exists, we're going to replace that flow key. I mean, there is no case in which we can optimize the memory utilization by knowing what was the previous state, what the current state of the flow table.
I guess the point here is that you're in more of the driver's seat if you're making the allocation decisions, and maybe it's something we don't want to deal with, and maybe it's something we want to push down to the switch to deal with. But one of the arguments was that you should be aware of the allocation decisions that are being made. You could say that the flow table, we're going to provide an infinite flow table abstraction, and we're going to provide intelligent caching of the smarter of the rules and stuff on the device. which would allow you to keep whatever semantics you want on the northbound of the flow abstraction, but require that you make, you know, allocation, insert, modify, remove decisions on the southbound. But that was one point. The other point was that there was a belief or a concern that there are a certain class of bugs that you will not find or that will emerge in production if you use an apply semantic. And that by using a insert modify semantic and thinking about the API in that way, there is a certain class of bugs that you could perhaps avoid. And these bugs are generally reconciliation bugs, or generally bugs that have to do with, you know, transient state. And you know, one of the reasons why I thought it was important to have this discussion, you know, with the larger group was because I wanted to look at the ONOS control plane design and have us decide that, you know, is this class of bugs which may appear in the circumstances that we have apply appropriately accounted for in our current approach. I'm not saying that there's going to be any benefit to applications. I'm not going to say that this additional accounting is going to make applications any better. But so the class of bugs we're talking about is, let's say you have a mastership change while you have writes in flight. Currently, we don't do anything on the new mastership side to do any sort of reconciliation before we allow new rules to be written. So if there are writes in flight and we just continue to do, you know, applies or whatever, I don't know. I don't know if there's I haven't worked through this problem for the FlowRule store specifically, but you know, it's definitely worth thinking about. Like, what are the race conditions? What are the types of conditions or errors or issues that can be glossed over? Another example would be if you subtly change the write key, or you have a bug in the way that you compute your key, and two rules look different from your perspective, or they look the same from your perspective. Knowing whether or not something's new or changing could result in, you know, the lack of or extra rules on the data plane that you weren't really expecting to be there. I mean, the point here.
I think it's interesting too, because, you know, in terms of what happens if different switches determine this is a modification versus a new rule differently, and you get different behaviors on different switches.
I mean, I think the idea would be that, yeah, well, yeah, I don't know.
For me, I look at it from an application standpoint. Clearly, it's a balance, right, between what control an application has, and with that control goes also awareness of what's there, versus the simplicity of being able to get something done. So I definitely see the allure of the apply model for the applications. Just make it so and move on, and not have to worry about running the reconciliation at the application level. It's certainly freeing, and having the systems below take care of it would be nice. On the other hand, with the reconciliation being taken by basically either absorbed by the driver or by the platform itself, does remove some level of control from the application for those apps that want to exercise finer grain. So I see I would consider a problem if we were to force all the applications to deal with their own accounting and making these distinctions and managing the complexities. I think that would be a fail, frankly. So I think we do need to, at some level, apply or preserve the apply semantics. I don't know what level would continue to absorb them, but I think it would be good to have it so that apps don't have to worry about it if they don't want to.
I guess I would argue that it's the controller's responsibility to do with that complexity. If you want to hide that from apps, hide it in the controller. Don't necessarily push it down to the protocol.
Yeah, I think I agree with Sam. I think the place I'm looking at is probably the FlowRule store or somewhere a little bit below that. Because when you write to that store, that's the only place you will realize, oh, this is a new operation, or this is a modify operation, right? And then the flow rule store, when it trigger the flow programmable or the provider, it should trigger a different API, and they know, if your southbound is sensitive to these two, then you need to use a modify operation on that.
Sure, but that's not what I wasn't arguing against. That I was just so I was trying to highlight it from the viewpoint of the northbound API and application.
Yeah, I agree on that too, because my app just doesn't care. This is my desired state. You write it to the store. I don't care if that's overriding something else or not.
Yeah, and so. Okay, so I guess it seems like we agree that if there is a distinction or is a need for distinction, it needs to be absorbed somewhere on a controller side, either within the southbound or within the kind of the distributed layer. I think actually it may need to be some absorption done at both places, because as I think it was David who pointed out, different behaviors from different switches, different expectations from different switches. That will have to be absorbed by the drivers, and then, but I think the overall state of management with respect to what is already there versus what is new, that clearly has to fall within the realm of the store.
I think we lost.
Yeah, so I think, yeah, but I still feel that having the duplication in a driver is not necessary to solve this problem. You mainly have that to solve the other problem, which is allowing user to swap the pipeline dynamically, right?
Yeah, this is one of the reasons I thought that duplicating some state was useful. Again, the main problem here is that the flow rule are translated to something else. So the representation change and depends on the pipeline that is on the device. So I needed a place where to store the final representation of the state instead of the original one.
Yeah. So in this case, the P4 device seems to require a new layer of abstraction somewhere, right?
Well, they already have this. They already have the device mirror.
Yeah, but I guess the thing is that the device mirror is inside the driver, right?
Yes, it's inside the driver. Yeah.
So what if let's say a user want to change the driver?
What do you mean?
I mean, you say the user could potentially change the pipeliner or the way translated into the P4 rule, right? In dynamically. And have you also consider a user can change the driver completely in the runtime?
No, I've not considered that option. I think if a device is a P4 runtime device, I don't see why you should change the driver. But anyways, I think this is a little bit out of scope. I mean, changing driver. Again, here the problem is that I needed a way to store the final representation of the table entries.
Yeah, but what I don't understand is that you need that for what? You need that because the translation can change from time to time?
Yes. Well, the plan, yes, at some point is to enable swapping the pipeline in ONOS. So you can have the same flow rule that initially.
If you don't change the driver, how do you swap the pipeline? I'm just curious. What's this use case over here?
If you don't change the driver, how do you swap the pipeline? Sorry, I'm not sure.
The pipeliner is part of the driver, right?
Yes. Well, the pipeliner in current ONOS architecture, the pipeliner is part of the pipeconf. The pipeconf can be seen as an addition to an existing driver. So what do you do? You have a P4 runtime driver that you extend with the pipeconf behaviors. And if you want to swap the pipelines, you basically update at runtime those behaviors that depend on the pipeline.
Yeah, but if you change the pipeline, you also need to change the, for example, fabric pipeliner, right? And how is that supported?
But I don't see why this is related to this discussion.
No, it's not really related. I'm just trying to
Yeah.
understand that what
Yeah,
is
so
the reason that you say that the translation could change in dynamically.
Okay, I got it. So
we can probably bring this offline. Yeah.
There are two translations. One is from flow objectives to flow rules, and one is from flow rules to table entries. The second translation is where we map a flow rule to the P4 program specific field names and actions.
Yeah,
Those
that's
are
the
defined.
interpreter, right?
That's the interpreter, correct.
Okay.
Now, this mapping depends on the pipe conf, on the interpreter. Okay. So if I change the interpreter, it might happen that one flow rule that before was being mapped to some match fields and some actions is now mapped to a new set of match fields and actions. They're equivalent, but maybe they're slightly different because what I did, I just optimized the P4 program, right?
Okay.
So if I don't store if I don't have a way to store the final representation of the table entries, when I want to, for example, apply a flow rule after the pipeline swap, I don't have any more reference to the previous table entry.
Yeah. Okay.
Yeah. So that's the reason. But I agree that probably we can investigate more time and make this more efficient.
I still have some questions, but I'll follow up with you offline. I don't think we should discuss over here. But regarding the place where we should have those distinguish between add and modify, I still think somewhere in flow service is probably a better place, because in that case, even you change to other driver, let's say an OFDPA one, right? Then your driver can still benefit from, your driver don't have to implement the logic to distinguish these add and modify again, right? If your flow manager, when you trigger the flow rule provider, it already has a different API, then you know what I'm saying? I'm saying that the distinguish shouldn't happen in the device mirror. It should happen somewhere in the flow rule service. That's my argument.
Yeah. So your argument is that this distinction should be more of a ONOS level logic rather than driver specific.
Think about you swap to another driver, and the other driver is also sensitive to add and modify. You just don't want to implement the same thing again over there, right? And the flow rule store already has the ability to tell whether a flow is a new one or it's updating an existing one, right? So I think the flow rule store is the perfect place for this.
Well, actually, the reason why we had this meeting today is because because of this proposal to P4 runtime to actually add a new mode, update mode that that simply applies a given state to a device. And doesn't make any distinction between insert or modify. It seems, I hear that. It seems that there is the feeling that instead making a distinction between the two, it's useful to detect a class of bugs, as Brian said.
So I mean, I think the thing, right, is we could easily implement insert or modify or whatever, implement it on Stratum and have other people implement it the same, and just ignore the fact that there's a difference between these things at the controller level. Like we could absolutely do that. It's not a big deal or a problem at all. The question is, keeping track of this state is a little bit, maybe it's different than what we do today. So it's a little bit more work from that perspective, and it also might require a slightly more accounting, and it might also require potential additional round trips if you get it wrong. But the question is do we believe that this class of bugs exists, or that this class of bugs is a risk, and is it worth paying the price for dealing with it?
Yeah.
If you don't believe the class of bugs exists, given our architecture, then we ignore it. If we don't think that the class of bugs is likely to occur or likely to be impactful, then we ignore it and we move on with our life, right? But what I wanted to do is make sure, at least within the ONOS community, that this loop was closed, because we effectively have a nondescript kind of ambiguous bug report that's potentially foreshadowing based on others' experience.
I see Jordan's in the call. I don't know if Jordan's, do you have any opinion or feelings on how, if there is such a class of bugs? I mean, from a distributed system perspective, having this distinction between insert and modify operations. I mean, what are the benefits?
So the one thing that I heard Brian touch on was resolving issues after mastership changes, which I think currently is a major issue with the distributed systems components of ONOS, and that's where I see the biggest problems. Before, like Brian was saying, when operations are in flight from a previous master, we currently do nothing to sort of resolve those in-flight operations before continuing to make progress on a new master, and that's definitely a major issue currently with the current implementation. That's mostly where I see the issues.
I see, but yeah.
But even if I don't know that an insert and modify would be helpful there. I mean, it might require you to be aware of it, because it means that what's going to happen is as soon as you start doing writes, if you haven't resolved your in-flight operations, like if you had an insert on one node, change master, and now you're trying to change the flow, then your modify is going to fail, and that failure is going to be something that gets logged potentially. Maybe you retry it automatically, but it's a bug that you're like, oh, okay, well maybe I should reconcile my state before attempting to do my modify, and I'll realize the flow isn't there that it should be there. And then I'll just do insert with the new value. Something like that. I don't know. I mean, the other problem that we had in the past was devices would change flow rules. So they'd come back in reconciliation and be different. If you did a modify to a rule and the key didn't exist, and you were expecting it to exist, you're going to get a new rule, but then the old rule kind of stays there as a ghost, potentially. Subtle changes in the key, either by the switch side or the controller side, like bugs, bugs in implementation, could result in additional rules being on the data plane, and those rules, at the best, are just taking up additional ASIC resources, and at the worst, could be impacting the way flows move through the system, depending upon how they get matched.
Well, it seems that it's not clear if there is. I mean, what I hear is that it's not clear if there is a specific class of bugs. Getting back to the original question, if there is a specific class of bugs that we can identify by having this distinction between insert and modify. So it seems that after the discussion, I don't have more stronger arguments to support our P4 runtime proposal, but at the same time, I don't have less arguments to drop it.
Again, I think insert or update is lazy on the client side, right? You should know, and I think there will be errors because people start using, hey, just put it out there, and if it exists, great. If it doesn't, put it out there, and I think we will see errors because of that. But that becomes an opinion thing more than anything else, probably.
Mm-hmm.
I mean, I think the biggest class of bugs that we've encountered is this class of bugs where either an application is buggy or you have multiple applications that are writing to shared state or shared tables with overlapping rules. In the case of apply, they'll just get in a war about, just changing things over and over and over and over again. Whereas if one of them has an insert that fails, then maybe there's some other logic that needs to be invoked. So that assumes that the client's looking at return values for their flow inserts, which who knows if that's even happening.
Yeah, but yeah, it comes back to good client best practices, right?
Yeah. But independent of this discussion, I think we could certainly do more to what Jordan was saying, which is around reconciliation of flow state on mastership change. So that I think is sort of an orthogonal discussion, and I don't know if this helps us think about that or not.
Mm-hmm. Well, I should have to drop off and take the train. I'm thinking honest, Thomas and Ray were able to get back online. Well, it seems that there is not much justifications for having this update mode in P4 runtime, and instead we still value in maintaining this extra bookkeeping in the P4 runtime driver. So I mean, if that class of bugs exists, at least it will be revealed. In this case, by a bunch of log messages.
Yeah, but it seems to me though that rather than forcing each southbound to do the reconciliation, kind of like what FlowRule programmable has to do today, it seems that at least I heard Charles arguing for moving that up to the FlowRule manager and FlowRule store specifically.
Mm-hmm.
Right? Is that something?
Yeah.
I
still think the driver seems a little bit too low for that resolution of or distinguish of add and update.
I agree, because I see with the providers, we specifically, architecturally, they're supposed to be as stateless as possible.
Yeah, and I can also imagine some other providers or some other drivers for the other kind of device would also require you to make this distinction, right? So maybe it's better if we just do that in the flow service.
Yeah.
And well, also, I was wondering, I mean, we do have a modify, an update on the store side. So we could maybe leverage that if the mechanism on which the entry is updated can be reused. Maybe that's a question for Jordan, I don't know.
Yeah, I think that's possible. That's true. It's kind of like a half implemented modify feature that's inside the store, but yeah, I think once you've solved problems with reconciliation, adding this sort of feature is useful. But adding this sort of feature is easy. But yeah, I'm still unsure about the usefulness of distinguishing between the two at a higher level.
But in the map events, don't we get insert, remove, or update? Like, isn't there a distinction?
Yes.
Doesn't the map know?
Yep.
That was my suggestion, to use the update from the map. I guess it needs probably the flow ID over there.
Well, what we may be missing is that there might, while the handshake between the store and FlowRule manager might be there already, and the distinction might already be kind of extractable, it's not clear to me whether we have that distinction on that piece of information passed along the south boundary, so to the provider. So frankly, we know the FlowRule manager and FlowRule service requires still has some bunch of deprecated things, which Ray can testify to, because he trips over those all the time. So it might be a good idea maybe to take a kind of a little bit of a step back and look at the FlowRule subsystem, even though it's a very, very key part of the system, and perhaps because it is a key part of the system, and just take a kind of look at it with fresh eyes, and not only actually remove and eliminate some of the deprecations which have been there for a couple of years already, but also potentially revise some of the southbound APIs to adjust them to make sure that we can create stateless drivers or stateless providers, and at the same time pass the information from the flow store about the distinction between insert or modify down to them. That might be worthwhile exercise.
I agree. And I also think that getting back to, I mean, having this smarter logic in the FlowRule manager and store, I think we should do it in a way that leaves to the driver the decision on where, to distinguish between insert, modify, and apply. Because, for example, in OpenFlow today, even if the OpenFlow specification makes this distinction, in our current driver implementation and switch implementation, we don't. We always use add operations. So, I mean, there's no really to have, for example, that extra complexity involved with, the current OpenFlow driver implementations. And there could be, devices in the future that do not make distinction between insert and modify, and instead use an apply approach. So I think in this case, the FlowRule manager, when asking the driver to write some state, to give an advice on which type of operation should be performed. But then again, yes, it's up to the driver implementation to decide what to do.
Yeah, and I wonder, since this is a fairly major thing, I wonder if this is something that we ought to perform this exercise on a 2.0 work stream. And leave the one stream kind of with the old architecture, some of the deprecation is in place and some old behaviors in place, and just focus the work on perhaps in the next release on the 2.0 stream.
Yeah, I would definitely keep this 2.0. And the other thing I was going to say is that I think we have something that mostly works today. We keep track of the accounting there. My suggestion is that we keep our proposal to the P4 runtime working group open, and we don't push it forward just yet, but just leave it kind of on the back burner. And then through this investigation, we can determine whether or not our architecture requires or would benefit from knowledge of insert versus update. And if we find a strong case through the investigation for keeping it the way it is, then we proceed with the proposal. And if we realize through our investigation that it would be more advantageous to have knowledge of when these operations are happening distinctly, then we can just we can drop it at that point.
Sounds good.
Yeah, I agree with both points. I think we should move it to 2.0, and we should keep the discussion open on the P4 runtime side. Also because maybe some other points that we did not foresee will come from that side.
All right.
Is that okay, Carmelo, or do you feel differently?
No. I agree with you. I feel the same as you. Things work today. It just this accelerated complexity kind of bothered me. So I wonder, that was the point of discussion today. But I think this is the best thing to do. So let's leave the proposal open, and let's think more about this.
All right. Well, that sounds great. I know that you have to head out, Carmelo. Don't you?
Yeah.
And we're past the time anyway. So thanks everybody for a really productive discussion. I'll upload the video shortly. And also, if you wouldn't mind, when you get a chance, maybe on a train, send me the link to the slides so I can link them to the presentation on the TST page. Okay?
I will. Okay.
All right. Thanks, everybody. Have a great day. Bye-bye.
Bye.
See you, bye.
Break point here. I can show you something.